Assalamualaikum warahmatullahi wabarakatuh. My name is Hafif Fikri bin Zunani. Now we want to present about the properties of the metal and the phase lag. In our group, we have 5 group member. There is me, Hafif Fikri bin Zunani, Nur Arif Ifwan bin Muhammad Nazaruddin, Muhammad Azri bin Ahmad Fauzi, Muhammad Hidayat bin Saifullah, Ahmad Izzat Imran bin Alias. We are from Faculty of Electrical Engineering. Our consultant company is DPI Consult Sdn Bhd. DPI Consult Sdn Bhd is the one of the consultant company that involved in engineering. The objective of this video are to study the properties and characteristics of 316L stainless steel. Next is to observe the strength-stress relationship. Next is to study the basic of tensile strength testing and to compare and contrast the tensile properties of original and cold rolled 316 stainless steel. The problem statement is there are many methods to predict failure on the stainless steel structure, but sometimes accident happens and it might endanger life. The need of assessment of method for crack stainless steel is important because of the structural engineering is increasing important for safe operation and maintenance.
I want to explain about the stress strength graph. From A to B, the extension is proportional to the applied load. Under this relative lightly loaded condition, the metal is showing elastic properties. From B to C, it can be seen from the graph that the metal suddenly extends with no increase in load. If the load is removed at this point, the metal will not spring back to its original length and it is said to have a permanent set. The yield stress is the stress at the yield point, that is the load at the B divided by the cross-section area of the specimen. Usually, a performer will add 50% of the figure to allow for a factor of safety. From C to D, the extension is no longer proportional to the load, and if the load is removed little and no spring back will occur. The point D is referred as the ultimate tensile strength when refer extension graph, or the ultimate tensile stress when referred to stress strain graph. From D to E, the specimen appears to be stretching under reload condition. In general, value of load and extension of limited use then applied to one particular size of specimen, and it is more usual to plot the strength state.
Today I will explain about what the relationship between the microstructure and the mechanical form. The microstructure of material such as metal, ceramic or polymer can be strongly influence physical properties such as strength, hardness, ductility, high and low temperature. For the mechanical properties, is also used to help classify and identify material. The most common properties considered are strength, ductility, impact resistance, and fracture toughness. Most structure material are anisotropic, which means that their material properties vary with their orientation. I will explain about the relationship between the strength, ductility, and the grain boundary. So first of all, the smaller grain size will make more boundaries exist. When the more boundary exists, more obstacle to dislocation mentioned. So it will make the higher stress, and finally it will make high strength, lower ductility.
If you look around us, there are so many buildings are use 360 LSS, such as Petronas Twin Tower. Alloy 360 LSS is a chromium nickel molybdenum austenitic stainless steel. It will develop to provide improved corrosion resistance in the moderately corrosive environment. Here the austenitic structure. This structure will give you the excellent grade in toughness. 360L stainless steel also offer the high creep, stress to rupture, and tensile stress at the evaluated temperature.